We are looking at angles in circles. Some of this we've already done. If you took geometry last year, Paige, you should probably already know this. Alright, central angle is an angle whose vertex is at the center of a circle. And its measure is equal to the measure of its intercepted arc. Yes. If that's your circle, would someone go draw a central angle? Go ahead. No. A central angle. Draw what a central angle looks like.
I can't draw a straight line.
That's perfectly fine.
I did better with my left hand.
Okay, Scott.
Okay. What is the angle measurement of that angle?
180.
Okay. So if this is 180 degrees, what does this arc have to be? Oh, that is one. That should be 180. What would that have to be? Nope, 180. They are the same. Does that make sense?
Are they always?
Uh-huh. Someone go draw another central angle. You can have a bunch of different central angles.
So it could be like a chord, and it would.
A what?
I know what a chord
No, not a
is.
chord. No, not a chord.
Okay.
I heard core, C-O-R-E. No, y'all are drawing diameters. Okay, Scott.
That's not a center. Oh, you got like
It
this?
is just the same thing.
Or, I don't know. I can't even copy this paragraph because everybody's like over the board. Or I can get back. That's what I did.
Okay. That works. Is that a central angle?
No, that's all right. But I don't get how that's central angle. I don't get it. It's just been another angle. Oh wait, is it an angle from the vertex?
It is an angle that has its vertex at the center.
I thought we were saying like, you know, like the one that goes all the way across. I have a question.
Okay.
Okay. Why does that one get to be a central angle, but the one goes straight down?
Well, it's the same. It's the same thing as what was just drawn.
But it's still. It's
Yeah, it is. It is. It's just we already had that picture. Okay, so what does this angle look like it is? Pick a number. I don't know.
100.
It's like
It doesn't matter. What would this arc be?
Oh my God!
Does that make sense? Y'all see how that works?
That was a Christmas tree. So the rest of it would be. There's only 200.
Yes. That part would be 300. Okay.
Where it's like one thing is here and then you multiply it by 2. And
We'll get there. Any questions on central angles? Okay. All right. So, angle 1. It is what? What's it called? Central angle. Why is it a central angle? It starts at the center. Central, center, central, center. Make sense? So whatever angle 1 is, the arc AB is the same thing. They're equal to each other. We're about to do that one. Well, yeah, we're about to do that one.
where you have to double it and
Yeah.
maybe two. Molly, you just confused.
Any questions on central angle?
I like circles. I just don't like the number part.
I don't like shapes. I'm going to fail geometry. Like so bad. We'll have to all 3 years.
Yeah, unless you got gifted math, and unless I'm not here.
I'm not getting out of gifted math.
Then unless I leave for some reason, yeah, you'll have me.
But you can't get it.
No, but your ACTs should get you out of, what you're taking now is basically what they're doing for dual enrollment college algebra. And it's called college algebra. But it's like basically what you're learning now. They didn't learn it in Algebra 2. Like, they didn't do well in Algebra 2. Most kids do Algebra 1, geometry, Algebra 2 their junior year. And then they do pre-cal if they can handle it. And they do like Math Essentials or something if they can't. And so, trig, or pre-cal trig. In college? In college? Yeah. It's what you'll be taking. Yeah, it's what you're going to be taking your junior year. Mm-mm. And usually your ACT score will get you out of some of those classes. Like your math ACT score.
It's a good score.
It should be. And then
I'm taking it this Saturday.
that's why your project is due Thursday. That's why your project is due Thursday and not so that you don't have to worry about it this weekend.
Well, I have other projects to worry about too.
Yeah, if it was due next weekend, I probably wouldn't get to the project done. I'm glad it's due this week.
Yeah, because it gives me a motivation to finish it.
I understand weekend,
I knew what she meant. All right, so an inscribed angle has the vertex on the actual circle. And this is the one where it's equal to half of the arc. Someone want to go draw an inscribed angle? Nope. Mm-mm. It won't go through the center usually. Is that an inscribed angle? Yeah, it does. Okay, what do you want this angle to be? Okay, if this is 20, what is this arc? Does that make sense? Okay, will someone go draw another inscribed angle?
I've got a question. What is
The central angle goes through the center. The inscribed vertex is on the circle, not at the center. It's like on the actual circle.
Wait, do it in green, do it in green. Is it in green? It'll be a Christmas tree.
It's not gonna be a Christmas tree. It's not straight.
You can't even see it. Wait, it can't be curved, Casey.
I just drew it back. It's straight.
Okay, that's his angle. What do you want your angle to be, Sean?
It has to be like, that's like 2 9. No, that's like
more.
3. It's not 180.
Okay, 170? If that angle is 170, what does this? It'd be what? 340? You think? Why 340? Double it, right? Does that make sense? Any questions here? Okay. So, what kind of angle is angle 2?
inscribed?
Inscribed. How is it related to arc AB?
It is half of that.
It is half of the arc, or the arc is double the angle. It's the same thing, depends on how you word it. Yeah, that's why I get it to draw the circles for me.
I think we should all have iPads with like built-in Wi-Fi, and then we can
Yeah.
do stuff like that.
It'd be really nice.
No,
And it'd be nice if like your tests, you could take them on your iPad and then like email them to me, so then I wouldn't have to read like some kids have terrible handwriting. Just some of my students.
my luck, I'd be like, I don't know how to write that on the computer.
Well, I mean, like you could have like scratch work, or you could type it. That'd be nice. Like on this, where I can type, or I can just write it. Any questions on these? I think that's it. Yeah. You could, but I don't know like why you would in math, because most of the stuff like you wouldn't want to do on the computer. English? I took notes in physics, like partly on my computer, and then I got tired of carrying my computer. I took honors classes in college, like through the honors college, and those were all I used my computer. Yeah, good luck with that. All right, so looking at new angles in a circle. If two lines intersect inside a circle, the measure of the angles formed equal half the sum of the measures of the intercepted arcs. Yeah. I got told one time. I was planning my wedding, and I was texting my husband asking him a question before he went to work, and I got in trouble, and I was like, okay. So yeah, I was really embarrassed. Like, I wasn't trying to be disrespectful. I was like really trying to ask the question. It was like at the very beginning of class. I'm trying to ask the question before. No, I was just like, yeah. I mean, I wasn't trying to hide it. No, but he was just like, Miss McElroy, you can put up your phone now. I was like, okay. McElroy. McElroy.
I bet that was hard to pronounce.
Yeah. Usually it was like Molly Blondin,
That's the one.
Jason Miles, Claire. Like, I never got a last name. They just gave up. Alright, so those are two lines that intersect inside a circle, right? Are they intersecting at the center?
No.
They don't need to. They can, but they don't need to. Let's say that the two arcs are 70 and 80. Just picking random numbers. This arc is 70 and this one is 80. The way that you find that angle, you say 70 plus 80 divided by 2. You add up the two angles and divide by 2. This angle and this angle are both x because they are vertical. Because this point right here lies inside of the circle, 1 and 2 equal each other, and the way that you figure out what they are, you say angle or arc CD plus arc AB, you add those together and divide by 2. This arc angle right here and this angle.
I have a question. Okay, so would x be 40? Why not? Because I thought you were doing the...
It's vertex on the circle. It's like just in the circle somewhere. So that's where you do the 70 plus 80 and divide by 2.
What if you don't have that angle?
It'll have to give you this one and this one.
Well, it never gives us the middle one.
How would
Okay.
that be like? It's not... Okay. I don't know.
This angle, what is that angle? That's what you're trying to figure out. They are. They're both 75 degrees.
So that one's 75. You automatically know that's 75. So it's always divided by 2.
They didn't give us that it was 75. We found that it was 75.
Look at the bottom one.
So let's figure out what angle 1 and angle 2 are. They tell us this arc is 60 and this one is 30.
Wait, angle 1.
Yes, angle 1 equals angle 2. So they both equal 45 degrees. Does that make sense? Okay. So that's if two lines intersect inside of the circle. If they intersect outside of the circle, similar concept, but instead of adding, use subtract and then divide by 2. Do what? It'll like go over it briefly.
Yeah, I don't understand what you want.
That's one way to draw it. Another way to draw it is like that. The two lines still intersect outside of the circle, right? Yeah, it just shows where they stop, but you can draw it where they keep going.
Would you please allow all stopping signs? Thank you.
You can also draw it like that. Have we learned tangent?
Yeah.
This is a tangent line?
Oh, yeah, that's learned.
Oh, okay. Well, a tangent line to a circle intersects it at one point, so that line's tangent, but these two still intersect outside of the circle. Does that make sense? So that's another type of picture. Does that make sense? Okay, so let's do an example. Yeah, 50 is this part. Any questions on where the 200 and the 50 go? Okay, so we're looking for that value right there. So we're going to do what? Does that make sense? Does that make sense?
I mean, okay, so just the equation I guess is gonna figure out.
Do y'all see how that works?
If all else fails, big number. Why?
Yeah, the big number comes first, because otherwise you'd end up with the negative number.
Yeah.
Yeah, no negative numbers for angles. Just like for distances, no negative numbers.
Okay, so what is the formula?
The large angle minus a small angle divided by 2 gives you the angle on the outside. They won't always ask for this angle. Sometimes they'll give it to you. Okay? Let's do one like that, where they tell you that this is 10 degrees. They ask you for that one, and they tell you this one is 100.
Okay, always do the outside one, right?
No, sometimes they'll ask you for the outside one. But what is... Okay. No, not necessarily.
Because you know that you said like the inscribed angle when it's like that, the outer angle would be like 200 and then the inner would be 100 because it's divided by 2. Why doesn't that work for this one?
Because it's not on the circle. Like it's just pulled away from the circle. All right, so for this one, what would the formula be that we would set up?
Okay, I'm thinking 100 minus x.
10 equals the outside angle equals 100 minus x divided by 2. Does that make sense? So you can guess and check, or you could actually just solve it. 20 equals 100 minus x. So what does x have to be? Does that make sense? But you can't always just say the big angle that they give you minus the small angle divided by 2. Because sometimes they'll give you the outside angle. But it's the large arc AB minus the small arc CD divided by 2 gives you the outside angle. 2 times 10. Multiply, cross multiply. Right here? Does that make sense?
I don't remember you got 10.
I just made up the numbers. The 10 and the 100 and the X, I just put them there.
Okay, so this is very confusing.
Do you understand the concept of the formula?
I know when you got the numbers, like you can make them up, but I'm just confused on where you get the 10 and the 20.
You always just say this angle, this arc angle, minus that arc angle, divided by 2 gives you the outside one. So 100 minus X and divided by 2 gives you the 10. And you just make it into an equation, and then you solve for your variable. Any other questions on these? Okay, so if they cross inside of the circle, what do? Add them? Okay. If they cross on the outside, what do?
Okay, big one minus small one divided by 2.
Difference divided by 2. Yeah. All right, so we got some examples. See if you can do them. Move up. Yeah, they are in the book, Jamar. They're on page 236.
Oh, that's big.
If you're worried that you're going to have trouble with these later, I would draw the picture. Does someone want to go write what you would do to solve A? Okay. Okay.
I got this. That one.
Do you agree?
Halfway between 80 and 60 is not 65. It's 70. Yeah. Okay.
Any questions on A? Okay, go ahead, Jamar.
Just think of it like 8 plus 6 is 14, 14 divided by 2. No. I just like to go halfway between numbers. I still got 60. My mental math. Oh, it's because did I add 80 plus 60 on? See, I got what to say. But 8, I think you put a 5 in the same. No, I thought 80 plus
Is that right?
60. 80
Hold on.
is hard.
Do you agree? Any questions on that one? Okay, Destiny?
Yeah, I know what you mean. Like, if it is like 16,
Oh, it's basketball game.
6, you're like,
Why would it be 24?
because like 8 and 6 get like 8 and 6 never work.
Do you agree with Destiny?
No. 70 minus
You set it up right, but then you added.
You added. See, it's hard. Mental math is hard.
There you go. Any questions on that one? Okay, somebody do D.
You're about to spit in your hand with a drink, but that is scary.
That's not smart, so I can't do
Do you agree with Jason?
But I don't understand this problem. I don't know what.
What's the largest outside angle? 280. What's the one that's closer on the inside? So 280 minus 80 is, and then what do you do? Divide by 2.
Oh, see, I did that, and then I said 280 minus, I said 180 minus 80 was 100 divided by 2. I was like, that angle is not supposed to be
Does that make sense? Any questions? Okay,